Hi everyone, welcome back. So now that we talked about equivalent fractions and what they are and how to find new ones and looked at area models and also saw how scaling actually works, now we can actually go into seeing if two fractions are equivalent. This might be a problem you come across when they ask you, are these two fractions equivalent? And you just have to think back, what is it that they're actually asking us? In this example, it says, is 1/2 equivalent to 2 or 4? In other words, is 1/2 equal, right, to 2 or 4? But since we don't know yet, we can put a small question mark up top, signaling that we're trying to figure out if they are equivalent. And then we can take it off once we figure out if they are. Now, one of the ways you can check is by drawing an area model, right? If we draw an area model, we can say, okay, then they are equivalent. But keep in mind that an area model might not be the best method, especially when the numbers get larger. See, 1/2, and we have 2/4, right? We can see that they are equivalent. But remember, this is just when you have a small numbers. But another way to check, for example, you have large numbers, if you can figure out the number that they were scaled by. Like, can you figure out the number that they multiplied the numerator and the denominator by, or that they divided the numerator and the denominator by? And if they have the same number, then you can say they are equivalent. For example, here we can see that 1 times 2 will give us 2, and 2 times 4 will give us 2 times 2 will give us 4. So now we see that they are equivalent because they are scaled by the same factor. So we can say, yes, they are equivalent. Let's try another example. Another example is, let's say, for example, 12/20 equivalent to 3/5. Right, and a small question mark, so that's what we're trying to figure out. Are they equivalent? Well, or you can draw an area model, but 20 is pretty large, so drawing an area model wouldn't be the best idea here. So you could do it though, but what we want to do is actually see if we can scale up or scale down, and we can see that 12 becomes a 3 if I divide by 4, and the 20 becomes a 5 if I divide by 4. Notice that we divided both the numerator and the denominator by the same number, so that's how I know that they are equivalent, as long as they share the same number. So in this case, we scaled down by 4. In this case, we scaled up by 2. So that's how they are equivalent. When you do have two fractions that are equivalent, they are called a proportion. That's a new terminology. So proportion. So for example, 1/2 and 2/4 are a proportion. Again, just a fancy word for two fractions that are equivalent. By the same logic, 12/20 and 3/5 are a proportion. And to simplify even more, a proportion is when you have a fraction equals a fraction, right? We have two fractions that are equivalent. When you have two fractions that are equivalent, they form a proportion. So these two are proportional. I'll do one more example of seeing if two are proportional. So please make sure you pause the video and try the problem out yourself first if you want to, and then you can go ahead and see if you get the same answer. Let's go with, for example, 7/21. Is that proportional to, or is that equivalent to 1/3? As mentioned, you have to figure out a way that you can get you can make one fraction to the other, and they have to share the same factor. So is there a way that 7 becomes a 1? Well, if I divide by 7, that becomes a 1, and if I divide this one by 7, I do get 3. So they are a proportion. Another thing I want to talk about is you can actually go backwards, so you can actually write these going this way, right? So 1 times 7 will give you 7, and 3 times 7 will give you 21. So we can now say that 7 over 21 and 1/3 are a proportion. In other words, fractions that are equivalent, fractions that are equal to each other. The next video, we're going to talk about another method to see if two given fractions are equivalent to each other. And the next method is actually I would say it's the best method, because you can see you don't have to draw it out, and sometimes you might get really complicated fractions with decimals in them, or even fractions within fractions. So the next method we're going to talk about is cross multiplication, and I think that's the best method to see if two fractions are equivalent to each other. But this is, again, the beginning part of it. Try these out again on a separate sheet of paper and then follow along. So just to summarize, two fractions are equivalent if you can figure out a way, you find a factor that multiplies or that divides, both the numerator and denominator to get the new equivalent fraction. This is without the area model. You can always draw an area model, but the area models might get too large or too small depending on your fraction.